let's talk about some things that I felt were especially important in working on phase 1. So this is such an important point that this is the entire slide. When you're trying to build a big, complicated system like Project 2, you want your complexity to arise through easy to understand interactions between relatively simple pieces. Okay? You don't want to have, and I'll give examples of ugly ones, just hugely complicated classes that are trying to talk to each other in weird ways, because it's going to melt your brain. You can't hold it all in your head at once. So instead, complexity should really feel like a natural outgrowth of all these simple pieces working together in a friendly way. Okay? Now, along those lines, I will say that even if you try your hardest to do this, you're still going to end up building a bunch of code you throw away. So in my case, I tried 3 different algorithms for drawing a world, spent a lot of time on it, ultimately threw that work away, and then, well, I guess, if I were a student in the class, I didn't get graded on that in any way. But actually, I did learn a lot. Even me trying it out, I learned some things about this specific problem that I thought were pretty interesting. Okay? So that's very normal. If you build something, you may have to destroy it. That's how it goes. Now, some other along those line tips. If you find that you have some big, complicated, ugly, not working properly piece of code that you're trying to debug and you're just spending a lot of time on it, sometimes it's better, rather than try to fix a broken, ugly piece of code, just throw it away and rebuild the same thing you are trying to debug. Often that's faster and you end up with something you're happier with. Similarly, if you actually have a piece of code that actually works, but it's also ugly and complicated, which I had in my case, well then what you can do is refactor it. That is, change the code in a way that the functionality is unchanged, but it's better, it looks nicer, it's more elegant, and just do it a little bit at a time. Don't try to change like 6 classes at one time, hoping to take a big complicated functioning system and shrink it down, because you'll break something if you do too much at once. So the refactoring process should be done a little bit at a time. Another tip is that I would say that JUnit, it has its place, as we saw in Lab 5, but there are a lot of things that are basically impossible to JUnit test. So if you want to know, does my particular world have an L-shaped hallway, a hallway with a turn in it, that's going to be extremely hard to write a JUnit test, not worth your time. And last tip on this slide is make sure that you break big tasks into small ones. And I'll give you some examples about bringing together this complexity through easy to understand interactions between simple components and breaking big tasks into small ones here with this visual example. So one thing that I find that 61B students really want to do is write big, complicated methods that operate at the lowest level of abstraction, because it's natural, right? You start thinking, okay, well, what is this L shape here? Well, I can imagine writing some complicated for loop that like goes through each column and it has to do something fancy, and you have some indices that are getting incremented in strange ways, but that's going to be super complicated. Trying to write this as a maybe a nested for loops or a sequence of for loops, just going to be a mess. So instead, what you should do is really identify what are the conceptual components of this shape here. Okay, well, and I guess the big picture I didn't introduce here is there's a requirement in the spec, which is that you need hallways that turn. And maybe you decide that the way I want to do this is I'm going to write a method called draw L hall. Okay, what does it do? It takes 2 positions and tries to draw an L-shaped hall connecting them. And so a bad idea is what I've been describing here, is writing a sequence of complicated for loops that takes a TE tile array and adds a bunch of TE tiles that have the appropriate pound sign or dot. Okay? Now, a better idea is to maybe do something like, okay, well, what is a hallway that turns exactly? Well, I have a vertical hallway, I have a horizontal hallway, and then I have a corner. So here's a vertical hallway, here's a horizontal hallway, a vertical hallway, and a corner. These 6 here. And so if you think about it that way, maybe that's something easier, right? You could break it down into little pieces that you can separately test, even just visually, and then combine them into something beautiful. Another idea, there's many different ways to potentially do this. Another idea, and I'm not saying that any of these, or that either of these are superior, but a better idea than doing this very low-level approach would be, okay, well, maybe what is a hallway, an L-shaped hallway, but 3 L's? So I have this little L, a medium-sized L, and a big L. And so maybe this draw L tiles method you give it a specific character you want, and it will draw you an L of the desired coordinates of the desired size and the desired tile. Okay, so just a different way of thinking about it. In this way, what we see is we have a relatively simple idea conceptually that we compose it together with other calls to that relatively simple piece, and you end up with this nice, beautiful, high-level behavior without having to have big, complicated for loops. Now, another tip is consider different ways to meet the requirements, right? So if you find that, actually, you know what? I made a draw L hall method and it worked, and I feel really good about it. And it can draw all kinds of L hallways. It can go this way, it can go right and then down and so forth. But maybe I find it's just not working out for me. Like there's some other issue I'm having where it doesn't quite work with the rest of my program. Well, what I could do is actually abandon draw L hall completely. Now, I'm not saying again, right? I don't know if that'll happen to you. I'm sure there are really good solutions that involve draw L hall, and there are really good solutions that don't. But if you decide that draw L hall is not working for you for any reason, you can think about other ways to meet the requirements, right? There's no, like once you decide to build something, you're not forced to do so forever. This project is about picking your own goals, trying to meet them, and knowing when to cut your losses. And again, you're going to throw away lots of code, right? That's how it's going to go. So an alternate approach entirely, instead of trying to do L hallways at all, is to do what I'm going to call the emergent approach, as opposed to an explicit approach. So the emergent approach might be, okay, well, I'm just going to write a world generation algorithm that just happens to create L-shaped hallways instead of explicitly doing so. So maybe for each room, I randomly generate neighbor rooms that branch off the current room. So maybe I generate a room like this, and then I say, okay, well, I'm going to branch off from this position. So I open up that wall and then build another hallway. Or sorry, build another room. And so since a hallway is just a width one room, and I'm building this algorithm that just creates rooms and then branches off, if it just so happens that two rooms that are width one are right next to each other, you have just built a turning hallway. Okay, so that's a little bit of a subtle point and maybe a little confusing, but my point is that there's more than one way to meet any of the requirements. There are so many different things you might do. You could explicitly write code to try and do each aspect of the project, or maybe you just, something about the emergent behavior of the entire system is able to meet that specific requirement. Okay. And lastly, for this video, let's talk about redundant encodings of information. So just as you should not feel compelled to stick with the first idea you have and be willing to throw things away, neither should you think that the only way to store information is as a 2D array of TE tiles. So an example that came up based on a discussion after lecture today, or before lecture today, I had a student saying, hey, our algorithm occasionally makes rooms that overlap. I got these two squares, they overlap, it looks bad. So how do I fix this? Okay, or we're trying to think about how to fix it. Well, the naive approach would be to directly analyze your TE tile array and say, okay, how do I detect overlapping rooms? What's the telltale symptom of this? And you could do something complicated involving pound signs and saying like if, I don't know what it would look like, but it would be a very daunting challenge. A more convenient approach would be, as you're generating rooms, keep track of what is a room? Well, it has two corners, right? A top right and a bottom left, let's say. So we create maybe a room class that tracks the corners of the room. And while we're generating the world, we keep a list of all existing rooms. And then maybe our room class has an overlap method that you can ask if it overlaps another rectangle. And if so, then maybe just don't use that room. Like don't actually generate that room. And in that way, by having this redundant encoding, we can do things that would otherwise be very difficult. Okay, so consider doing something like that. So I know this is all pretty vague, right? I mean, this is not your 61A style, okay, hey, when you're working on the, I don't even know. I don't know the 61A projects well, so this is going to not sound so good. But rather than saying, hey, for this specific method, think about this specific thing, because in this case, the world is your oyster. And I hope you find this experience useful. I mean, this is something that you won't get to do necessarily a lot, even in later upper div courses. I mean, when I taught 188, there were plenty of projects that were just fill in the method. So this is really your chance to find your own challenges and try to solve them, and I hope you enjoy it. So it'll probably be scary and challenging for many of you, but don't lose heart, and I hope these tips were helpful. All right, good night.